7th today, I think. What I'm working on is taking out my electricals, so I'm going to try to get the batteries ready to get pulled out. So this is the cabling here, the positive and the negative, that go over to the electric motor. And then I have an electrical shut-off here, a breaker switch, or a manual override here, basically is what that is. So I've got that turned off right now. And then all of my other, this one here would be part of charging for my solar. This is the main feed, the negative feed for the motor. I believe this is actually the solar panel. It's been a while since I've looked at it, so I'm not 100% certain. So what I'm going to be doing is these are sitting on this side of the shunt, and then you can see here this goes over to the battery. So the reason why it's designed this way is so that charging gets read by the shunt. So that way I get negatives and positives both reading, depending if I'm drawing or putting energy into the batteries. Let's get cracking. I've got lots to take out. Alright, so my power is off, so I have no power at the moment. So what I'm going to do is I'm going to disconnect the main feed across my batteries. So my batteries are all in series, and these are the only two connection points I have on them. So I'm going to take that out, and that'll basically just disconnect my entire system. I'm just going to go really slow. Whoa, see, that's what I didn't want to do. Oh, let's get this stuff off of there. Okay. Going to keep going. Basically, I'm just going to dismantle the wiring and then pull these batteries out. And right now I can't charge this camera because all my power's off. But those batteries weigh 65 pounds each. They're pretty heavy, considering they're small. And I don't have a little grip handle to lift with, so I kind of have to get them and wiggle them and make it so that I can work it with my hands here. So I'm going to just struggle with that. Saying I pitied the fool who was going to take those things out after. Because I said, I'm not taking them out, but here I am taking them out. Those things are heavy. First we take this thing out, move it over here. This is the process I go through to get them out. So what I've been doing is I've made this little rope carrier to go through here. Tie that up. And now I've got a handle, which I can barely lift the things as it is. Okay, so I get it up on the ledge, and now I lift it up over top of my controller.
Low power.
What is it they say? Every foot vertical that you go up a ladder or down a ladder, it's like equivalent of like 10 steps forward. It's hard going. The ladder is the hardest. My legs are shaking from the workout here. It's an extra 75 pounds basically. 67, 70 pounds, I can't remember, but something like that, 67 or 72 pounds per battery. So I've got 450 pounds of batteries that I'm taking out, and I'm replacing it with, right now, 100 pounds of batteries of the lithium. And I'm going to have a little bit less, but I think I'm actually going to have a little bit more draw when I do some tests. So with the lithiums that I picked up, these Ampere Time ones, they're 100 amp hour lithium batteries, and they're supposed to be able to be drawn down to 80%, which will give me about 80 working amp hours. And my old batteries, the lead acids here, the 6-volt deep cells, were like, you can't run them down all the way, right? So like, I was always paranoid about the battery levels, and it's just due to risk of damaging the batteries. So like, I never really ran them down, hardly 10%, maybe 15%. But the kind of the magic cutoff's 100 or 50%. So in theory I had 100 amp hours, but I don't think I did, because it seemed like when I needed the battery power, it's like I was running out all the time after, like, crossing through the canal at 5 knots. I depleted my batteries. I was down at 47 volts just going through the canal, which was about, say 10 minutes of running. So like, the batteries couldn't handle it. So that's why I'm switching. So we'll do some tests, and yeah, we'll see how it goes. It's pretty cramped. I can't really get in here, but with these batteries in the way, I'm looking forward to being able to get in here. Okay, but I should be able to get these bolts off, and then I can finish off the rest of the cables being off. Alright, so I'll get that side there. Alright, so we've got new lithium batteries. So these came up as Ep117 100 basic, so they're 100 amp from Ampere Time, and this is just an unboxing. Okay, so in the top of the box, there's a little slip here, and it looks like nuts and bolts. And nice foam packaging. Oh yeah. So it's basically the screws here for the mounts. Oh, that's nice. Comes with a strap. I bought 4, and I'm going to be connecting them up in series. That's the intention. And this is nice and red, this is nice and black, so it's pretty easy to tell which ones to connect to. But I'll read the manuals here now, I'll see if there's any other caveats. But there's no way to tell another battery what they have. So I know that inside of these, I'll do a little sit down afterwards and just talk about the battery a little bit. But I do know it has a BMS inside, and it has kind of like overcharge, undercharge, some different cutoff points. But it has overheating, but it doesn't have cold. So I'm going to have to use a relay temperature sensor from my MPPT controller and stop charging when the temperature gets below certain degrees. Okay, so just finishing off on this Ampere Time unboxing. We'll give you this thing here for the manuals. So I did get a product manual, and I got a product brochure. And the product brochure basically gives you some basic information about every one of their batteries. An operation guide, I guess, like this is what I call the quick guide. And then there's I guess a brochure on the company, talking a little bit about how they make their products and why they picked the square cells instead of the round cells, that kind of thing. Maybe there's a couple things I didn't bring out here. Was that they do have a 5-year warranty. You do have to ship it to their U.S. Office, warehouse, shop, whatever they call their building, where they work. But they do that, and then they give it to you. They'll investigate it. They'll either give you a new one, or they'll repair it or whatever, and give you it back. But you have to send it to them. So they won't give you one, I don't think, like a drop ship replacement. So you'll be out of a battery for a little bit. And so one thing I didn't know, just reading through the information here, was that the legal regulations for shipping is only 30 to 50% charge. So I didn't understand why they, like everything I watched, actually this wasn't clear. They don't ship them fully charged. They only ship them with a 30 to 50% capacity charge. So it's just sort of enough to keep going. And then when you get it, they ask you to charge it with a charger. And I wasn't too sure I understood why that is. So they want an operating voltage of 12.8 volts. They have a charging voltage of 14.4 volts. Max continuous load, 1280 watts. And the max continuous charging current is 100 amps on these batteries. And the discharge is 100 amps. So it's that's fairly good. And when you put them in parallel, you can increase your amp draw. So with having two of them in parallel, you actually have 200 amps because the load gets divvied up between the two batteries. So for my motor actually peaked. I could push 200 amps to it, but I think it would be just flying. So in my case, 100 is tons. I'm considering changing my electricals to put a breaker in, and I'm just thinking about that for a bit. It's like, what size of breaker do I want? Because you want to be able to use it, but you don't want to be able to hurt the equipment. So it's set to 225 amps right now in the controller. So I'm thinking I'll put a 200 amp circuit breaker in front of my motor, which I didn't have before. It weighs, was it 23 pounds? I think it was. Let me just find that here before I say that again. So a couple of, let me see this, find out. So the recommending charging is 14.2 to 14.6 volts, and the recommending charging current less than 100 amps. So it doesn't seem to be like a fancy charger or anything, at least what they're saying. It's just make sure the voltage is 14.2 to 14.6 and then it will charge. So the battery, the BMS inside, I'm assuming is on right now because there's voltage, right? So when you go to charge it, the BMS is going to be kicking in or out. So what the recommended inverter settings to use with this battery is the charge voltage is 14.6 volts. The over voltage disconnect is 15 volts, and the float charging voltage is 13.8 volts. Low voltage disconnect, they're recommending 10.8 volts, which is actually quite low. And the low voltage reconnect voltage, they want you to bring it up to 12.4 volts before you turn on the battery, I guess. Yeah, so I'll, let me just, there was one thing, chart here that I was looking for that I found very useful. The case is IP65, so it's great for the boat. It's an ABS case, so basically like plumbing. And here's the charging tips. Based on the characteristics of lithium iron phosphate batteries, the voltage measured by all LiFoPo4 batteries during charging is not the real voltage of the battery. Therefore, after charging and disconnecting the battery from the power source, the voltage of the battery will gradually drop to its real voltage. Well, that kind of makes sense, right? If you need to test the real voltage, please charge and disconnect the power supply and test the voltage over 15 minutes. So for the battery charger, it's saying use a 14.6 volt lithium iron phosphate battery charger to maximize the capacity. Recommend charging voltage between 14.2 and 14.6 volts. So at 20 amps, the battery will be fully charged in around 5 hours to 100% capacity. At 50 amps, the battery will be fully charged in and around 2 hours to about 97% capacity. So at a 50 amp current, it takes about 2 hours to get to 97% capacity. So that's pretty significant. So the Quattro that I'm looking at is going to be maximum 35 amps. So assuming I could push that with a generator, it's going to take somewhere between 2 and 5 hours to charge. So maybe like 3.5 or 4 hours to charge. So that would mean that from a total discharge state, I'd have to run the generator for 3 to 4 hours to get myself to like a max charge or a peak charge on the batteries, which is kind of interesting. So I just got to think about that for a little bit. It is 35 amps at 48 volts, so I should be able to do 4 of these batteries all at the same time in that. And then it says, okay, charging or select user mode to enter values according to the parameters below. So they do give you the float, over voltage. They give you all the numbers here in the product guide, product manual. But the one chart that I wanted here, this is actually the one thing that I wanted. They do give you a chart, so I'm just going to include it here on the screen. I'll take a picture of it. And that's the state of charge. So at 13.5 volts, it's 100% charged. At 13.4, it's 99. At 13.3, it's 90. 13.2, it's 70% charged. 13.1, 40%. 13.0, it's 30%. 12.9, it's 20%. And 12.8, it's 10%. So really what I need to be doing, and I don't have my phone on me here, but 12 times 12 is 48. Sorry, 12 times 4 batteries is 48. 0.8 is 8 times 4, which is 24. So that would be 48, so it would be 50.4 volts is my cutoff for 10%. They say 1% is 10.8 volts. So to me, the curve is just going at that point. So between 10 and 1%, they're saying 10.8 volts is the low voltage disconnect. So don't let it go more or less than maybe 42.4 volts. So they're saying if it goes below that, you're harming the battery. But that's at 1%, so I'm like, who's going to do that? But actually the good part about this is that at 12.8 volts, that would be 50.4, yeah. So that means that if I'm seeing basically 50.4 volts, I should never see less than that when I'm motoring. Although that doesn't say what it is after draw, so I don't know. I guess that's one of the things. When you have no draw, what's the voltage? But when you're drawing the voltage down, what does it get to? So I got to pay attention here and see actually how it behaves. But that chart's actually useful to kind of give me a guide. So when I could be able to figure out using my battery monitor, what is the current voltage for the whole system, and I'll know roughly I'm 30%, 40%. So I should be able to tune that, I think, with the Victron Energy Cerebra that I bought. Yeah, and you could do up to 4 identical batteries in parallel or series. So if you really want 48 volts at 100 amp hours or 12 volts at 400 amp hours when they're in parallel, those are what you do. Those are the ways that they're suggesting to do it. And they give you some kind of methods and direct guides on how to actually do it. One other thing I liked here in the manual, because I was wondering about this, the BMS will cut the voltage off on certain points. So if the battery has to cut off for protection, you need to cut the load off the battery and put the battery aside for 30 minutes. Then the battery will automatically recover itself to normal voltage and can be used after fully charged. But if the battery is unable to recover itself and the voltage is too low to hold the charge, you can activate it in a couple of ways. Use a charger with 0 volts charging function. It can charge the battery starting from 0 volts to charge the battery. After it's fully charged, the battery can be used normally. So you need a charger that actually can work at 0 volts. And then another one is that to use another 12 volt lithium battery to connect in parallel with the battery for a minute to activate the battery. So that would be kind of like just take the energy of a good battery and put it into this other battery by running them in parallel. So connect the positive to the positive and the negative to the negative. And as long as it has more than or equal to 12 volts and less than or equal to 14.6 volts, the BMS will allow it to charge. And it's saying that after a fully charged battery, and it can be used normally. And they are suggesting that you can use a lead acid battery. if required, which is good because I've got an extra lead acid battery. That was one of the things I was going to put up in the front for the windlass. A 12 volt battery up there separate from the system to give me the ability to offload the power draw just for the windlass because it's all the way up in the front. And then I thought, okay, I could use the system to keep that battery charged. Yeah, so that's kind of that's the end of the unboxing of these Ampere batteries, and I'll be doing some field tests this year with them with the boat, and I'll let you know how they go. I'm really longing for spring. This is see the dark. It's coming at us. It's like one storm after another, it seems. Anyways, I got all the batteries out before the rain, which is good. It's +3 today. And, now I'm just going to grab the bottom of the battery box and get that out. Basically, I think I just mounted it in with these screws here on the sides. I got 1, 2, 3 on that side. And I got 1, 2, 3, 4, 5 on that side. And I think this whole box comes out. You can see I put a couple of supporting pieces on the bottom to hold it. So the wall things were probably overkill, but yeah, did a good job. Never moved at all with 600 pounds on it. So gonna call that a day for now. We've got a little bit of hail coming down. I'm gonna go pick up some bus bars and things, basically, for some of my power distribution points I'm gonna work on. And then I think it'll make my connectivity a little bit easier, simpler for some of my units. So I'm going to draw it out, but I'm going to go check the electronics store and see if I can pick some up there. They're probably a little cheaper than the marine store, but I want ones that have a cover on them instead of just an open or an open exposed bus bar for the DC power. Yeah, so I'm going to do that now. So anyways, next step, one step at a time. And I think that after I run some tests with kind of like the same equivalency roughly, I'm gonna buy, if I like them, I'll buy another set of 4, and then that'll get me up to 200 amp hour lithium, which I think is going to be plenty for what I'm doing. I'm going to have a generator hookup and the Victron Energy Quattro, so I can have shore power or generator charging at 35 amps. So I'll be able to basically run the generator, and at least in theory, and be able to motor on the electric motor for quite a distance as long as I have gas, basically. So that's kind of my backup plan to the motor. So we'll see how it goes. Alright, so just closing off I've still got some more details on this